Filippo Bosi. I'm the CEO of Imola Informatica, who is hosting this Lunch and Learn. Hi, Claudio. Okay. Just a few words about us, but I invite you to go to our site if you're interested in knowing something about Imola Informatica. We are a consulting company based in Italy, in Imola, and we offer consulting for banks and insurance companies in Italy. Our lunch and learn are informal meetings about technical subjects, so I won't steal you much time. I just wanted to say you welcome and thanks, because this is the first event in English. So thanks to Italiana Software, who has organized the meeting. Thanks to the microservices community, and of course to Ballerina. Claudio is the CEO of Italiana Software.
Hi everybody. Hi Filippo, thank you very much. Hi Anjana, thank you to be here together with us. Just a brief introduction about microservices community, and I think that everybody is curious to know about Ballerina, not about microservices community. Microservices community is a community that we started some years ago, initially as an informal community, and step by step it started to grow. And the main objectives of the microservices community is to put together academy and industry, and also professionals, in order to have a reference, a community reference for sharing ideas and techniques about microservices and distributed architectures in general. So this is one of our main objectives, is to organize events and to also try to find a new link for increasing our network and making projects together. So if you are interested in the microservices community, just check the website, microservices community. There is an open free chat on Discord that you can join freely, for free, and then you can have discussion there. So thank you very much to be here again, and I think Filippo, we can leave the Anjana I think that Anjana can start with the talk about Ballerina.
Yes, I have to remind you some rules. Okay, keep your microphone switched off and webcam off while listening to the meeting. And when asking questions during Q&A time, switch on your microphone and your webcam. And if you have questions during the presentation, please raise your hand or write down your questions on the Teams chat. Okay, Anjana, it's up to you.
Okay. Thank you.
Stop presenting. I'm stopping.
Can you see my screen?
Yes.
Great. Okay. Hi everyone. So welcome to today's session. So today we'll be talking about Ballerina. It's an open source cloud native programming language. I'll go through a bit of the history, like why we have started this project, why a programming language, what's the requirement, and so what's the basically the use case and the need for such a programming language compared to like other solutions. I'm Anjana Fernando, so I work at WSO2. WSO2 has been producing software for enterprise middleware for a long time now, almost like more than 15 years now. So we have a history of creating this enterprise middleware, specifically for integration and API management. Ballerina actually came from this background. How the motivation behind it is, we are always finding better solutions and approaches to solve these network integration problems. And like you may know, like increasingly now we are doing network-based solutions when you create applications. So it's not only like general monoliths, but you turn to external services to create like composite applications. Like you use external networked services to create an application. So so modern, especially enterprise application now has become an integration problem. So that they have basically converged together. So the applications has become integration solutions. So we wanted to like find a better way of writing these, especially these cloud native applications. Either like, so we wanted to find like, okay, what are the tools? Should we create a DSL, a specialized domain-specific language, or any other tool, and so on. So at the end, we ended up actually coming on to saying, okay, we need a new programming language with these concepts built into a language itself. So the problem was the existing languages didn't have these concepts, these abstractions built in. So people usually put on frameworks and other bolt-on like libraries and so on to get some of these features. So we wanted to do something from scratch, add these concepts, abstractions into the language itself. So that's how we came up with Ballerina. So Ballerina is what we called an agile network-aware cloud-native programming language. So we try to solve and make it easy for a developer to write cloud-native programs. So the language itself, I'll be going through some of the features, some of the prominent features, explain a bit, and I'll be doing some hands-on demos as well to get a feel of how it is. So you see like basically in action. The language itself is very much like a C style language. So you'll be like people who have programmed in like C, Java, C#, JavaScript will be like familiar with the syntax and so on. So on top of that, we have, so as you will see, we have created these abstractions and unique features to make it easy to do like cloud native programming. So I'll start with services in the language. So again, it's a first class citizen of the language, like how you do network services. So you can again do like normal main programs also, but we have another entry point called services. So for example, let's see this scenario of I'm going to do like a HTTP service where I'll call a send request and I'm sending back a simple response. Let's see how this is shown in Ballerina. So these are typical anatomy of an HTTP service we have in Ballerina. So this is the basic syntax. So we have, as you can see, a service structure, and we can give the information regarding the service and the resources that it exposes. So the service type is defined by the listener that you attach to it. So here it's we have a specific service. Service name will be here the base path of the HTTP service, and this has become an HTTP service because we have attached an HTTP listener to it. So in the same way, we do gRPC, WebSocket, Kafka, and so on. All these type of services are supported with its own resource format. So here in the HTTP service, we have a thing called the resource functions. We also have a type called remote functions. So there are two types of functions that are supported in a service. Basically, a resource function represents a resource like which something that is represented with a noun, basically, like a thing. And a remote function is something you do, that is a verb. So in gRPC scenario, that will be gRPC functions are represented with remote functions, but in HTTP, those become resource functions. So here I have done a greeting. Again, it's I'm getting a greeting, so I'm modeled it as a noun here. So let me quickly show this in code as well. So I'll quickly show how Ballerina program is created. Let me increase the font size. Anyway, never mind. Let's okay. I'm going to create a new package called hello. So that's basically how it's like the project concept in Ballerina. So your main building block is a package, and so I'm going to use VS Code here. So we get some like template code automatically generated for you, Ballerina Thomas, which is the configuration file for your package, and this is the default some main method. So I'm going to switch it to a HTTP service. So and let's model that simple greeting service that we saw earlier. So that's it. So now it's a matter of running the service. You can just say bal run and run this package, and it runs the default module that we have. In a Ballerina package, we can have multiple modules. So for example, that I have imported a package, the HTTP package here. It can have other modules as well. So here we are using the default module in the package. So it can have other multiple modules as well. So in the same way, I am running the default package in my program, default module in my package. So the service is running. You can just do a simple curl and see. Likewise. So this in Ballerina, this service, these functions are modeled in a way that it will map to the certain protocols semantics. So here, the remote resource function, we call it the function accessor. So the accessor can be specific to the transfer protocol. So here in HTTP, it's the HTTP method that we use. For example, I can say post, and it will only allow post request. So in this way, you can't actually do a post request. It says method not allowed. If you just say post, and I can say something like, I will do actually a data binding scenario here. Okay, let's see how this works. Let's say we are giving a name. Yeah, you can see we get hello Jack and so on. So we can easily modify this the function to take in parameters like payloads, query parameters, path parameters, and so on, which I'll show more in detail in next sections. So, we support hierarchical resources as well. So in the service resources, for the service name in the HTTP scenario, we can have for the name separated by these slashes, so which will represent the hierarchical resource. And the hierarchical resources also can be parameterized as well. So we can give parameters, so this can be read in later. So here also, let me implement this scenario. Let's say so it will do the conversions automatically. So we have mentioned it's an int. So, oops, get, oh. Like that. So it does the validations automatically. So if you give something else, it says you can't, of course, convert it and pass. The resource won't be executed, and so on. So so it gives you a lot of flexibility in this manner. So you can also give something called a REST parameter, which is like a sort of like a args in what you will find in other languages. So it's like multiple values for a parameter. So here in this manner, you can implement scenarios like catch all the subpaths in a specific base path. Likewise. So those kind of scenarios can be implemented using like mixing and matching with the combinations that we have here. So in the same way, we match, we can provide the query parameters as well. Query parameters basically are given using the resource function parameters. So if you just give parameters here, they become query parameters. So that means I can give like likewise. So in this way, we can mix and match query parameters, path parameters, payload, like data binding, and so on. So so the main thing is, so as I mentioned, all of these syntax are dependent on the type of the service. So in the HTTP service, this is the behavior. In other scenarios, the behavior of the resource functions will be different. So I'll also a new feature we have with the latest Ballerina version, Ballerina Swan Lake. So this new service format is actually available with the Swan Lake release. So actually, at the moment, it's in alpha stage, but we'll be releasing a beta release in April actually. So which will actually be ready for prime time usage actually. So let me quickly show you a GraphQL service also to show like how these different types of services work. name. So this is also similar to the HTTP service. Okay. So here, the GraphQL, the query type, the field is mapped to this service here, the root query, and a field in the GraphQL, the query object are represented here as resource functions. So these are basically similar to these are basically the resolve functions you would find in other languages as well. So here again we can provide parameters for the fields and so on. So in this way, when you need a hierarchical scenario, you can return another service instance which will contain another object. So for scalar types, you can return like strings, integers, and so on directly. If you have another object, you would return a service. A service will in turn again contain fields, either scalars or again in other objects. So here I'm going to just return a simple simple service which returns a scalar string here. Let's see how that works. Okay, our service is up. So I'm going to send a GraphQL like query here. So the query itself is actually this part. I'm just requesting the name from the root query. So as you can see, we get the response. So let's take a look at a bit more of a complicated scenario, which with more nested objects to see how it is. So this scenario models like a order information scenario where we have a GraphQL service which returns order information. And so the first entry point is this initial GraphQL service, which has a single field called order, and it has a parameter also. It has a parameter also called ID, integer one, which will give you obviously the order with that specific order ID. And so since it's an object, so it returns a Ballerina object as well. So which is defined by a service class here. So here that service class defines its fields can be scalars like this, or again in turn it can have other objects as well. So we have these nodes, date are like just string values, and the customer is an object which loads the customer and again populates that information. So it loads that information from a database using our database connector, and retrieve those records and basically returns an object which represents those information. So let's quickly run that also and see how that works. Okay. Okay. So now we can send GraphQL queries to this. So here I'm going to use this graphical tool called Altair to send requests. So it just renders it nicely. So this is the query. So I'm going to say, give me the order with 1, and I want nodes and the customer's name and address. So here I get the response. So I can optionally just only query other things as well. Customer has things like the ID. Nope, it doesn't have an ID. It has. It only has name and address. So yeah. Likewise. So you can do another ID also here. So yeah. So that's so you can basically the idea is you can nicely model these concepts with the Ballerina services. So as you can see here with the GraphQL, it nicely maps to the services and the objects concepts we have in the language itself to conveniently and intuitively model these operations. So it's easy to extend and scale these kind of scenarios. So this sample you can find here. So I have put all the links here in my presentation. You can go check it out later. So I'll get into some other specific language features as well, some of the unique ones. So let's take a quick look at concurrency. So in Ballerina, so it has a lightweight concurrency a construct called strands. So it's like a lightweight thread concept. Basically, one or more strands are like a thread, a physical thread is represented by one or more Ballerina strands. So basically what happens is we allow you to basically execute these strands, especially along with IO operation in an optimal manner. So let's say if you do a non-blocking IO operation, we have the ability to suspend a strand and continue it later. So that's automatically done by the runtime itself. So I'll show an example later in the slides also. So anyway, in Ballerina, so the strands are realized using this concept called workers. So we can explicitly define workers, and also workers are created in other places as well, like asynchronous invocation of functions with the start operation and so on. So we can explicitly create workers in functions in this syntax also. And we do communication between these workers using message passing. So using this syntax, you can send in variables to the other worker and send them back to the worker in the same syntax as well. And the compile actually checks these data interactions to make sure we don't have any obvious deadlocks. So it matches the send and receive operations and say like some of the operations cannot be done. If there's no matching receive operation for a send, that's a potential deadlock. So with that, so there are certain limitations on the things you can do here, but it makes sure that we do the best effort to make it secure as possible. So so another way of creating these more workers is these futures. That means if you have a function, you can execute it asynchronously using the start keyword, and you can check its status and wait for its result using the wait keyword. Like that's available here. So that's convenient when you want to just execute something in the background as a function. Now we come to the sync IO section. As I mentioned earlier, this works hand in hand with the concurrency model. So any IO operation that you do in Ballerina is a non-blocking IO operation. So if you do an HTTP GET POST, like any network operation, it's an non-blocking operation where your execution thread actually suspends, and the IO operation gets done through the operating system. And when the data is ready to be processed by our application, it continues our thread from there onwards. So we don't really block the threads, but this is automatically released and resumed by the runtime. So in other languages and So on they probably we generally use like frameworks. We use like callbacks to do these things, like these reactive extensions and all these things that are available in other languages. But it makes the programming experience very complicated, especially when you want to when you have like a big scenario with multiple callbacks and so on. It becomes goes out of hand like very quickly. So this approach makes it very easy. So this is automatically handled by the runtime, so you don't have to worry about those things yourself. And another main thing is obviously, when you talk about cloud native, we had to think about the deployment options as well. Ballerina contains like rich supports for like pluggable deployment options, including Kubernetes. So when you have like a, especially in Ballerina service, we have a convenient way of automatically deploying that to Kubernetes by looking at the actual like the code. So you don't have to do anything extra. It automatically creates the Kubernetes artifacts, and you can like deploy it straight away. Let me quickly show you a demo on how we can do that. So for that, let's take our simple like hello service and use that. So I actually go back to my early example. Oops. So this is basically what we have. And so earlier we just said Ballerina run or Ballerina build to run it directly or like build the executable. So Ballerina, when you say a normal Ballerina build, it just creates you a jar file. So if you do a bal build, oops. So Ballerina runs on top of the JVM at the moment. So one of the runtimes is the JVM. We are also working on a native execution runtime as well, as in to create native executables to be this specific target specific binaries. So that's still work in progress, but the JVM runtime is the most mature one that we have at the moment. So as you can see here, we just generate a jar here. So and we can of course do a jar minus jar and run it, or Ballerina run. Now another option is we can say for the Ballerina build command, we can say cloud equals Kubernetes. We can give the environment, a target environment where the Ballerina build should be done. So if you say cloud Kubernetes, it will automatically build the Docker image. It will push it to the registry, and also build the Kubernetes artifacts in order to deploy this to a cluster that you have. So let's see how we do this. Oh. Let me first. So I'm actually using a local Kubernetes cluster based on Minikube. So I had to set some environment variables to point to its Docker environment. Let me quickly do that. Oops. Okay, let me build that again. So just to show we don't, oops, okay. Okay, just to show that we don't have, well, actually we have. Let me delete this. Offering deployment. So it's the let me do some cleanup here. Okay. Things are clear here. Okay, actually lost my command. Okay, so in the after the build is done, it gives the instructions that you can simply execute this, and our deployment is up and running. Also, so you can expose this using Node port. Okay, let me get the command quickly. Oops. Yeah. Yeah, I just wanted this command. So we executed this, and what we're going to do is, so we have our service deployed now in Kubernetes. We just want to expose this to the outside. So I'm going to expose this using Node port. So you can see here, we have this now exposed through Node port, our service. Now we can give it a try to send a request to the service. So the port is 31230. Greeting. Yeah. So we see now it's going through, the request is going to Kubernetes. So as you can see, so without any code change to our Ballerina service, by using the cloud features we have, the deployment features we have in Ballerina, we were able to like quickly build the deployment to a target Kubernetes cluster. So moving on. So in the same manner, we have support for other like serverless environments as well. So here is a quick example on how a Lambda function would be written. So we have, for this, we have a annotation-based system where you basically quickly annotate your function and you have this specific signature, which takes in the Lambda context and the input message. Also, there are like event-specific data types as well, like for example S3 events and so on, which you can use here. So if you just say JSON, you will get the JSON message, or specific event-based types also are supported here. So for more information, you can check this user guide content as well. So again, then in the same manner, when you do a Ballerina build, Bal build, it automatically generates the zip file that you can use to deploy to AWS Lambda. So you can use the CLI or from the UI, you can deploy it directly. Same scenario with Azure Functions as well. There also it has an annotation-based system where you can create your scenarios, and in Azure, so there's a pretty powerful concept called the input-output bindings and triggers, where you can define your input-output these channels basically declarative in the code itself. So it makes it very easy to link specific functionality between functions and so on. So you can create very complicated scenarios using like minimal code. So for example, here, so it's a scalable sort of like a data processing scenario that I have implemented here with the OCR function using some Azure libraries. That whole thing is done by this code, doing the processing, going to queues, blob storages, and all these things are simply done using these annotations. So you don't have to worry about creating clients, loading credentials from configuration, and so on. All are done using this functionality. So yeah, that becomes especially useful for implementing these kind of like function as a service scenarios. So again, here when you do a Bal build, you get it creates the final zip file with the functions. You can just deploy them. Another prominent feature of Ballerina is like inbuilt observability. So any especially the network operations you do, they are by default observed by the system. So you can say, okay, observe this globally, and it'll track all these network operations and all these special activities done by the code. So especially since the code is aware of these network interactions, it can do this optimization and do this automatically. Let me do a quick show on how this is done. So we'll basically observe our hello world scenario. Actually, let's get a more complicated scenario. So let's do the this GraphQL scenario. So it has multiple like service operations and database actions and so on. So what we are going to do here is, so when you create a Ballerina package, it automatically adds these configurations saying observability included. That basically what happens is when you build your application, it embeds the code that's required for the observability as well. So the dependent libraries and all these things. So afterwards, then also in the runtime, you have to say when you're running it, enable observability. So I'm just giving it in as a config parameter here, observability enable. So if you put that, when we actually run it, it'll run with the observability features as well. So that's basically what happens here. How this is done is it creates a it has a Prometheus listener inbuilt into service. So the metrics are like basically served from this endpoint. And also it publishes tracers to Jaeger through this using the open tracing API. And so those are published out. So using these two, we can do metrics and basically distributed tracing. So for this scenario, I'll quickly run Prometheus and Jaeger. I'm going to run them through Docker. So it's easy to run it like that. Actually, Prometheus, Grafana for dashboard, and Jaeger. So then log into Grafana. Let's add the Prometheus data source. Okay, the data source is added. Then let's import the dashboard. So the dashboard is, we have a default dashboard for Ballerina. So I have downloaded JSON and let me use that. So we can see here, we automatically get the default observability feed, the stats we have already. So if I send some more requests to this, we should get more activity. Oops. Likewise, just 5 seconds. So you can see the sets are going up. And in the same way, so we have other sets as well for SQL queries and all. You can see here the services that are executing now, the failure rates, throughput, and all this information is tracked here. So in the same way, I'll quickly show Jaeger as well. So there are some changes that are being done at the moment for the Swan Lake release. So for the moment, at this moment, it doesn't show the service names properly. So basically, it provides the tracing information in this manner. The operations that are called from the service, like here, the get order in our GraphQL will service the field, and after that you go into this MySQL query and so on. So especially useful when you have multiple like services chained together. So you see the trace through the network. So here it's only the service and the database operation. So it's not that interesting, but yeah. When you have multiple, it's much better. So these are a typical example where there are multiple services there are multiple hops through the services. So you can optimize the invocation and so on. So this is what we saw earlier. So yeah, so that's basically a rundown through some of the prominent features we have in Ballerina, but we have many more features in the language. So like some of the features are mentioned here, like some more interesting stuff are like stream processing, distributed transactions, and all these things. We also have OpenAPI support as well to create subs from the OpenAPI configurations and skeletons as well. And also other aspects like Java interoperability. So if you have your existing Java libraries, you can plug them directly into this. Like either to direct dependencies or with like a Maven dependency and so on. And also we have a centralized package management system called Ballerina Central. So it's called central.ballerina.io. So here, that's the place where if you have your modules, you will basically push your modules into this centralized repository so others can reuse it, or your organization can reuse it in other projects, and so on. So basically, it's a convenient way of sharing the modules for use. Of course, there are other minimum network protocols that I didn't cover, gRPC, WebSocket, and so on. So which are also very interesting, and like on how they are modeled in Ballerina. And also other security aspects like taint analysis is also a unique feature in the language, where we do like static code analysis to check for possible data vulnerabilities, like if you are using like tainted data from outside, like user input or network data and so on in secured environments. For example, in SQL queries and so on. We can make sure data coming from outside are not used in an SQL query directly. So and so on. So we use a static analysis mechanism to find situations like that. And also, so there are other like tools and other surrounding platform features available to make the full end-to-end development easier, like starting from test-driven development, like we provide a unit testing framework and to do mocking, and also other things like documentation as well. So that makes it like a self-contained environment, like a platform to do the full life cycle. So again, this is an open source project. You can get involved. So the full source code for all the components can be found in this repo Ballerina platform, and you can. So most of the communication is happening to our Slack channel. So do join if you're interested, and you can ask questions in Stack Overflow as well, which is the Ballerina lang tag. More information you can find at ballerina.io website. So that's it for my presentation. If there are any questions, I can take them now.
Okay, thank you, Anjana, for this presentation. It's very nice and very interesting. I see that there is a question for you from Luca Cappelletti. It is Luca written it in the chat. How large is the Ballerina developers community and how it is growing year after year?
Okay, so actually, the Ballerina community, so comparatively, it's still not long compared to other languages. Like it's like a bit more than 4 years, as I know. So community, as in, so it's at the moment, the most of the developers are from WSO2. So we get like few contributions from other people time to time, but at the moment the majority is still WSO2, and we want to actually expand that. So we have some activity like other people basically. Mainly more users are there in Slack channel and so on, but not many from like code level contributions actually. So so we have like a healthy like a growth from the followers and the usage. But yeah, we are still comparatively in we have somewhat more to go to get more of a following compared to the mainstream languages. So that's our aim at the end. So yeah.
Okay, thank you very much. Are there other people that want to make a question? Okay, yes, I see that someone raised a hand. Saverio Gianlorenzo, you can.
Anna, thank you very much for your presentation. Also, given the time you are giving it, I have a question regarding serverless, because I noticed. I think I noticed something interesting. Everything is interesting, of course, here, but I have a knack for that.
Yeah.
So I saw that you might express how functions can call each other. Is it right?
Yeah, so this is, I think, in this Azure function scenario, I'm guessing, right? So yeah, that's actually a concept in the Azure functions itself. That's sort of how they model their functions ecosystem. So we were able to model that concept directly into the language again. Like compared to Lambda, like your triggers and so on has to be defined externally, and you had to call the functions, right? Yeah. So in the Azure functions, you can define this input and output in the parameters itself. So for example, so in this thing, I have declared saying this variable, things written into this variable are going to a queue, and it will go to the queue, and so on. And I have mentioned that here in the queue trigger, things that if someone puts something into this queue, trigger this function, and so on. So it's declaratively you can say how these functions are triggered and how things go into these other places. So effectively, if you put something here, this function automatically gets called. So it's you basically implicitly wire the functions together with this mechanism. So it's a very powerful mechanism we get from that function provided by Azure as well. So we just nicely integrated that to the language.
Yeah, it's nice. Thanks.
Yeah, no problem.
Thank you very much, Saverio. There are other questions from the chat. There is a question from Vijaya. Hope this is the right pronunciation. Very sorry if it is not the right one. Vijaya is asking, is HTTP server light or heavy?
So it's a lightweight server. So it's actually based on Netty. So so it's a JVM implementation. Our the underlying implementation is done based on Netty. So Netty is a like lightweight, high performant HTTP library. So you can so we have done like benchmarks and so on. So we perform very well compared to other competing technologies. So it's much more lightweight, and you can use like as a typical microservice. So basically one process per service. So we have optimized that for a lot to have a smaller footprint and for performance. So yeah.
Okay, thank you very much. We can continue. There is another question from Eddie Truyen, and he is asking, what about making Kubernetes concepts first-class entities?
So yeah, the first class as in, so actually in our earlier version in Ballerina 1.2, we had an annotation-based mechanism in the code. We sort of moved away a bit from that when in our like current version, because then your code binds to the specific deployment targets. So we wanted to like not to define that in the code itself, but it's a separate deployment action, right? So the code is kept clean without any modifications. So then at the end you can decide, okay, where should I deploy this service? Then you can decide, okay, I'm going to deploy this in Kubernetes, or in other options. Okay, like can be other type of deployment options. Likewise, that's why we got it outside and still provided the tooling from the compile itself to deploy them in like Kubernetes and so on. So we try to we basically make it like a first class feature from the platform to support Kubernetes, but it is separate from the code itself though. So any other so something actually I couldn't explain, any other customizations like Kubernetes, okay, scaling parameters, secrets, and so on, can be given with an external Kubernetes.toml file. So we have a simple format for that. Using that, you can customize those behavior. So if you try to define all of that in the code, you will get something similar to like the YAML format you find it in Kubernetes in the code itself. So we want to get it out and make it a much more user-friendly experience at the deployment part. So that's why it's designed in this manner.
Okay, thank you very much. There is another question from Vijaya, but if you agree with that, Vijaya, I will leave this question at the end in order to give space also to another question that came later, and then at the end, if we have space, we can also analyze your question if you agree with me. So the other question is from David Pash. I hope also this is the right pronunciation. How well does Ballerina integrate in infrastructure as code solutions like Ansible or Terraform?
Okay, infrastructure as code. So it doesn't have the typical infrastructure as code. For example, if you take Pulumi, so Pulumi is an infrastructure as code solution. So that means it's again, like other things, you can define the infrastructure from the code itself and like define these things. So it doesn't work in the same manner, but you can use Ballerina in those on those tools. So then it just becomes yet another like a programming language or like a target. But Ballerina itself does not try to replace that concept altogether, because that's sort of like a different thing. So what we give is like, we do give, like as I mentioned, for like Kubernetes and so on, like deployment options for this specific application itself, but we do not try to provide a tool to manage multiple applications and so on. So we only concentrate on Ballerina and that application being deployed to somewhere. So in other things, Ansible or something, you get like multiple things and you declare, you say, okay, deploy in that way. So it's not in the same level, or it's not in the same scope that those tools have. So we are just one application, that thing being deployed somewhere. So obviously, yeah, you can use Ballerina in those tools as well. That shouldn't be a problem.
Okay, thank you. I saw that someone maybe raised the hand. I don't know. No. So if there are no other questions, I can proceed with that. The last one of Vijaya that asked how is Knative fast support?
Yeah, Knative, we also have Knative support as well. So similar to the Kubernetes support. So if you can, so I'll point you to the documentation. So if you go to banner.io /Lake learn by example, actually the Knative one is not updated yet. Okay, so let me show you the older version actually. So there we have this annotation based approach. So in the same way we define the Kubernetes services, we just mentioned the Knative service here, and the special thing what happens here is, so it will scale to 0, right? So it works at like in a serverless manner. So you can give the properties here. So again, in the latest version also, in the same way we support general Kubernetes, we will be having Knative support as well.
Okay, thank you very much. Are there other questions for Anjana? Anjana, I have a question for you.
Yeah.
If you can imagine how will be Ballerina in 10 years, so just go to the future, and how can you imagine the evolution of this programming language, considering also the evolution of cloud computing, containerization, and all this kind of stuff?
Yeah, so yeah, our aim is to basically become like the #1 programming language for like cloud native development. So what we see here is like we don't see like, okay, compare like, okay, like languages like Ballerina and Jolly. So there aren't any languages that specialize on this aspect. So the problem with other languages is they have been designed for like, you know, like for before like long time ago, right? So then we didn't have these concept issues that we want to consider, this network communication and all these things. So what we are aiming is, so we have like sort of like a special ability sort of to fulfill those requirements. So so that's how we see going forward. So it will be like the go to like cloud native programming language. So other people will use to connect to multiple places and so on. So for microservice development and all these things. So that's the ultimate aim. So obviously it won't be like a short like a short time goal, but it'll take a bit of time until it catches on. So with as with the same with any other language. So adoption is key. So we just have to get the word out and hope people will give it a try. So yeah.
Okay, thank you very much. Maybe there is another question. I check. Okay, Nikolai, you can make your question.
Yes, hello. Thank you for your presentation. I had actually a couple of questions. The first one being related to the concept of security by design. And so to which extent Ballerina is embracing this concept other than SQL parameters and things like that. And the other one, or let's start with the first one, which I could extend to Claudio as well, talking about Jolly.
Okay, so I'll go first. So Ballerina, so whenever possible, we try to make sure the user does the correct thing, or actually we make sure a user will not get the chance to do the wrong thing actually. For example, so that taint analysis. So we make sure in the code itself, like the example you took also, SQL query, we make sure you will not give any derived data, derived query value that is from network data or user input or anything like that. We make sure that is enforced in that way. And also other places, like for example, in our authentication authorization functionality. So if you enable basic auth to a service, we make sure you cannot expose that using so by default using HTTP. So we automatically switch it to HTTPS. So people won't like mistakenly use HTTP with like basic authentication. So things like that. So subtle things we make, like we go with better defaults mainly to make sure that people won't get into trouble in that way. So there are many language features and also features in these like best practices in the libraries and the other things that we implement to follow this concept basically.
Okay, and the second question about the runtime environment, because you said that for now the main version of Ballerina runs on top of JVM, but you're trying to, or I think you're having another parallel project trying to run it somewhere else. The goal of this experiment, let's call it like this, is to improve performance, or are there any other goals?
Performance, so few goals, as in so one is less memory consumption, and especially startup time improvements. So mainly when you have native binaries, you won't have the overhead of JVM startup and so on. So in situations like scaling scenarios, like auto scaling scenarios in a cloud and so on, it's much desirable to have processors that start up quickly when needed. So compared to the JVM, if you have a native binary, it will be much quicker. And again, memory usage aspect as well. General performance after when things are up and running, I don't think, generally we don't see much of a difference, because JVM is, anyway, it has a just-in-time compiler, so things get compiled to native code eventually anyway. So they are as fast as the native code in the end. So when things are actually executing, when things are hot, we don't really see a difference in that manner. So the main areas are like the startup time and like initial memory consumption. So those are the aspects we are trying to improve. So the effort is based on LLVM. So we have done some work, but more to go until it comes to the same level as JVM.
Yeah, I see. Thank you so much.
Yep. Okay.
So thank you. And are there any questions again? So I think we can close here this interesting webinar about Ballerina. And I don't know, Filippo, you want to close this session? I closed. So thank you very much to everybody to be here. It was an honor for us to host Anjana to be here. In California, I think it's quite early in the morning, so we appreciate this effort from your side. I think that everybody enjoyed this webinar, and maybe, I don't know, maybe if someone have some other questions, I think they can contact you by email or through the Ballerina community as well. Yep. And so let's keep in touch with the Lunch and Learn of Imola Informatica. I think that in the next month, we also have other interesting public available webinar. And so thank you to all of you to be here together with us today. Bye-bye. Thank you very much.
Thank you. Thank you, Claudio.
Thank you.